Hi, welcome to another statistics solution paper. Today we'll be working on Winter 18, paper 6-1. 9 people are to be divided into a group of 4, a group of 3, and a group of 2. In how many different ways can this be done? What you want to do first is to know that you will use combination in this question. So 9C4 multiplied by 9 minus 4 is 5, so 5C3, and the rest is 2C2. This will be equal to 1,260 ways. For question 2, we have a probability distribution table where P is a constant. Find the value of P. So you have to realize that when you add all these together, you will get 1 as the total. So P plus 2P plus 0.1 is 1. So you will have 6P is equal to 0.9 and P is equal to 0.15. Given that EX, or the mean, is 1.15, find the variance. For this question, the formula will be squaring the x and multiply that with the probability. So to answer this question, you have for x is equal to -1 squared multiplied by 0.15 plus 0 squared multiplied by 0.15, which is 0, plus 1 squared multiplied by 2b, which is 0.3, plus 2 squared multiplied by 0.3, and 4 squared multiplied by 0.1. And you will subtract the mean square from this value. You will have 1.15 square for the mean square, so let's just change that to 1.15 square. And this will give you 1.9275, which is equal to 1.93. In an orchestra, there are 11 violinists, 5 cellists, and 4 double bass players. A small group of 6 musicians is to be selected from these 20. How many different selections of 6 musicians can be made if there must be at least 4, at least 1 cellist, and no more than 1 double bass player? So for violinists, for cellist, and for double bass. Now you have to have at least 4 violinists, so 4, at least 1, and no more than 1. This will all equal to 6. 4 plus 1 plus 1 is 6. So this will be, out of the 11 violinists, you will choose 4. Out of the 5 cellists, you will choose 1. And out of the 4 double bass, you will choose 1. Next, you can also have 5, 1, 0. Technically, no more than 1 double bass player can mean 0. And you can also have 4, 2, and 0. So out of the 11, you have to choose 5. Out of the 5, you have to choose 1. And out of the 4, you choose 0. Out of the 11, you choose 4. Out of the 5, you choose 2. And out of the 4, you choose 0. You will add these together. So you will have 6600 plus 2310 plus 3300. This will be equal to 12210 selections. The small group that is selected contains 4, 1, and 1. They sit in a line to perform a concert. How many different arrangements are there of these 6 musicians if these violinists must sit together? So there are 4 violinists, so 2, 3, 4, and then there are 2 spots available for the cellist and the double bass player. So you can just regard this as 1 unit, but you have 4 violinists, so 4 factorial multiplied by 3 factorial because you have 3 spots, 1, 2, and 3. And this will give you 144. It is given that x is shown. Find the probability that a randomly chosen value of x is less than 29.4. So p must be smaller than 29.4. This is the same as p, see 29.4, minus 31.4, which is the mean, and divided by the square root of 3.6 because that is the variance here. So draw your graph. If this is 0, your graph would be so you have to have a smaller than -1 something. So -1 is probably here, and smaller than that means you have to get this. So 1 minus. This is equal to 1 minus 0.854, and 0.146 is your final answer. Find the estimates for the mean and standard deviation of the length of fish of these species. So you know that if x is smaller than 12, you will have 42 over 400, which is the probability, or 0.105. So p, if x is smaller than 12, then z will be 12 minus mean, because you don't know the values, and the sigma. This is equal to 0.105. If you draw your graph, you will find that your number is a negative value because your area here is a small number. It's not larger than 0.5, so it's probably here, and smaller than that is here. So you know that this has to be a 1 minus. This is equal to 0.105. And your sigma is -1.253. Now for the other value, you know that if x is larger than 19, then z would be 19 minus the mean divided by the standard deviation is equal to 0.145. If you draw your graph, you will see that when z is larger than something, the area is a small number, so it has to be a positive number. So 1 minus 19 sigma is equal to 0.145. And eventually you will have 19 minus mu divided by sigma is equal to 1.5058. Now for the equation, I will equate the sigmas. So I will use the substitution method. 12 minus mu divided by -1.253 is equal to 19 minus mu divided by 1.058. So 12.696 minus 1.058 mu is equal to -23807 or 15795. To find sigma, I will use one of the equation, so 12 minus the full value of the mu before the estimation, 795, by -1.253. This will give you 3.0289 which is estimated to 3.03. A random sample of 9 students who will take this examination is chosen. Find the probability that at most 6 of these students will pass the examination. So at most 6 means x is smaller than or equal to 6. This is technically 1 minus the probability of getting a 7, an 8, and a 9. So 1 minus 9c, 7, 0.87, 0.22, minus 9c, 8, 0.88, 0.21, minus 0.8 to the power of 9. This is equal to 1 minus 0.30198999 minus 0.1342177. This will all equal to 0.262. A random sample of 200 students who will take this examination is chosen. Use a suitable approximate distribution to find the probability that more than 166 of them will pass the examination. So you have to find your new mu, your new mean, which is equal to NP. This is equal to 200 multiplied by 0.8. This is equal to 160. And for your variance, you will have NPQ. Q is 1 minus P, so 200 multiplied by 0.8 multiplied by 0.2 is 32. So for x to be larger than 166, P is equal to 166.5 minus 160 divided by the square root of 32. Now remember that for approximate distribution, this sign and this sign means minus 0.5, and this sign and this sign is plus 0.5. That's why I put 166.5 instead of 166 alone. This will be all equal to PZ 1.149 and 1 minus is equal to 1.149. This will equal to 0.125. For questions like justify the use of your approximate distribution, all you have to do is to find the value of NP and the value of NQ. For NP, our value was 160, and for NQ, our value was 40. Remember that Q is 1 minus P, so both values are larger than 5. For number 6, I have drawn the cumulative frequency graph, because you just plot the points that you see on the table to the grid, on the grid. So on 100 of the days, the rainfall was K millimeters or more. Use your graph to estimate the value of K. So it's or more. You know that this is near the right-hand side of the graph. So out of the 250 days, you only need 100. So 250 minus 100 is 150 days. So at 150 days, the rainfall was, in my grid, it was 42, so 42 millimeters. Now, since what you have is a group data, so to calculate the means, the estimates of the means and standard deviation of the daily rainfall in this village, you have to have a table. So this will be rainfall, X millimeters. This will be frequency. This will be the middle value of the rainfall. This will be xf, and this will be x squared f. So for x smaller than or equal to 20, I can just write 0. I can add 0 in front of it. $100. To find x, you have to calculate from the graph. So let's go back to the graph. In order to find the frequency of this group alone, you have to subtract 52 from 94. So you will have 42. So for the x smaller than or equal to 30, your value is 42. I don't want the cumulative frequency, I want the frequency only. So for x is smaller than 40, your frequency will be 142 minus 94, which is 48. And for this one, you have 30. For this one, you have 50. And for the last group, you have 28. So it's basically the right-hand value minus the left. Let's go back to the table. So this will be 52. This will be 42, 48, 30, 50, and 28. For the middle value, what you have to do is to find the middle value of this rainfall. So for for 0 is smaller than x smaller than 20, you have to add 0 and 20 together and divide that by 2. So your middle value is 10. Now do the same for the rest of the groups, and I will fast forward this until I get to the end. For xf, what you have to do is multiply the value of f and the value of x for each of the groups. So for the first, the value is 520. For x squared f, you have to square the value of x and multiply that with the f. So 200. To calculate the mean, you have to have the sum of xf divided by n. So if you add everything here together, the sum of xf will be 9980. So 9980 divided by 250 is equal to 39.9 millimeters. Now to find the variance, what you have to do is to find the sum of x squared f divided by n minus the mean. So if you find the sum, it will be 533,300 divided by 250 minus 9980 divided by 250 squared. You will get 539.59 millimeters squared. Now since you have variance and what you need is the standard deviation, you can just square root that value. So square root of 539.59 is 23.2 millimeters. Find the probability that a randomly chosen student is studying music. So what you have to do is to add these values under music. So 40 plus 12 divided by the total number of students, which is 160, and you will have a simplified value of 13 over 40. Determine whether the events a randomly chosen student is a boy and a randomly chosen student is studying music are independent, justifying your answer. So first what you need to find is the probability of choosing a boy. And what you have to do is to add these values together for boy. So 24 plus 40 plus 32 over the total number of students, 160. This will give you 3/5. For a randomly chosen student is studying music, you got that value earlier, which is 13/40. And what you have to find last is that it's a boy and that boy is studying music. So if you look at the table, for boy and music, it's 40 over 160, so 40 over 160. In order for events to be independent, the probability of getting that should be equal to the probability of getting a boy multiplied by the probability of getting student studying music. So it will be 1/4 is equal to 3/5 multiplied by 13/40. And the results would be 1/4 is equal to 39/200. But these values are not equal to each other, so these events are not independent. Find a probability that a randomly chosen student is not studying drama given that the student is a girl. So not studying drama given that the student is a girl. This will equal to, let's look at the table. Not studying drama means adding these values together, and the total number for girls is 64 by adding 15, 12, and 37 together. So 15 plus 12 divided by 15 plus 12 plus 37, which is the total number of girls, and that will give you 27/64. 3 students are chosen at random. Find the probability that exactly 1 is studying music and exactly 2 are boys. So I need the probability of getting a boy studying music multiplied the probability of getting a boy not studying music and probability of getting a girl not studying music. I will also need the probability of getting a girl studying music multiplied boys not studying music. So for this question, I will use the combination formula. So for boys studying music, there are 40 students, and I will choose 1. Multiplied out of the 56 boys not studying music, I will choose 1. And out of the 52 girls not studying music, I will choose 1. Add this with the probability of getting a girl studying music, which is 12. I will choose 1. And since these two are the same, I will just write 56C2. And divide everything by 160C3 because I want to choose 3 students and there are 160 students in total. This will give you 0.201. Don't forget to hit like and subscribe. See you next time.